Hello, everyone. So let's get started with our warm-up question. So we have an object that is moving at a velocity of -4 meters per second, and it accelerates at a rate of 2 meters per second every second. So what would its velocity be at 10 seconds? We have 4 choices today. Is it 2 meters per second? Is it -24 meters per second? Is it 16 meters per second? Or is it -8 meters per second? So if an object is moving at a velocity of -4 meters per second, and it accelerates at a rate of 2 meters per second every second, what would its velocity be at 10 seconds? So pick the answer that you feel like best solves this problem here. We currently have 19 people and we have 6 responses. So we are about a third of the way. So for those of you just joining us, please answer the warm-up question. If an object is moving at a velocity of -4 meters per second, and it accelerates at a rate of 2 meters per second every second, what would its velocity be at 10 seconds? We are currently at 11 out of 20. Let's see if we can shoot for 9 more. We are at 17 out of 21. Let's take another 2 more minutes or so, or until we hit 100. We are at 18 out of 21. We're at 85%. So we are pretty close to hitting 100%. If you're one of the last 3 people, please answer the warm-up question whenever you are ready. An object is moving at a velocity of -4 meters per second, and it accelerates at a rate of 2 meters per second every second. What would its velocity be at 10 seconds? Let's take another minute or so to answer the question if you haven't already. Let's take another 30 seconds or so. We're at 19 out of 22. If you're one of the 3 people who haven't responded yet, please do so whenever you're ready. All right.
My answer choices aren't popping up.
If you aren't your choices are not popping up, which has happened before, just message me your answer.
What are the options again?
2, 24, 16, 2, -24, 16, and -8.
Okay.
Okay. So as we are going through this, let's start with figuring this out. So first off, what is happening in the problem? So initially, the object is moving with a velocity of -4 meters per second. So what does this negative mean? What does this velocity mean? So the velocity tells us that the object is moving, right? And it has a negative velocity. So what this means is the object is moving 4 meters per second in the negative direction. right? So it's moving 4 meters per second in a negative direction, which means it's essentially moving left or down. And that's what the negative is. The negative tells us a direction. Now, when the object is accelerating at a rate of 2 meters per second every second, what this means is that every 1 second, our velocity increases by 2 meters per second. So initially, if we were looking at our time and our velocity, initially we were moving with a velocity of 0 meters. When time was equal to 0, our initial velocity was -4, right? We were initially moving at -4 meters per second. After 1 second, we accelerate by 2 meters per second. So our velocity actually increases by +2. And so after 1 second, it goes from -4 to -2. So here it actually increased by +2. After 2 seconds, our velocity increases by another +2. So it increases by another +2. So now we are at 0 meters per second. After 3 seconds, it increases by another +2. So we're at 2 meters per second. And we can keep doing this forever and forever and forever until we hit 10. But that seems a little slow. So let's see if there's a faster way of doing this. Well, what we want to do is we want to take our initial velocity, which is -4, and we want to add, and our acceleration basically tells us how much is our velocity changing per second. And so if we want to figure out our final velocity, we want to figure out how much is my velocity changing in total. So in this particular problem, our velocity is increasing by 2 meters per second every second. So what this means is after 10 seconds, my velocity should increase by 2 times 10, right? So if my initial velocity was -4, it's going to increase by 2 times 10. And so in other words, it's going to increase by 20. So our final velocity would actually be 16 meters per second. So let's see how we did this. So first off, we took a look at our initial velocity, which is -4 meters per second, which means we are essentially moving 4 meters per second left. And every second, our velocity is increasing by +2 meters per second every second. So after 1 second, it increases by +2, so it's -2. After two seconds, it increases by a total of +4, or within that second, increases by +2. So it goes to 0, then it goes to 2, then it goes to 4, et cetera, until we stop and we hit 10 seconds. So what we can do here is we can just figure out if our velocity changes by +2 meters per second every second, that means in 10 seconds, it should change by a total of +20. So, but we're not done there because it changes by a total of +20. What we still need to do is we need to combine it with our initial velocity. So if our initial velocity was -4 and it changes by +20, that means our final velocity should be +16 meters per second. So that's pretty much how you might take a look at the problem like this. There are a few misconceptions here that can be easy to sort of misunderstand here. The key here is we want to realize that our acceleration tells us how much our velocity changes every second. Yeah. Is there a formula for these types of problems? There is, and we will figure that out today. But for now, I want you to do these stuff conceptually. I want you to think about it conceptually first before I give you a problem, before I give you a formula for this. So that is for the warm-up problem. What we are going to do next is we are going to move on to the next slide. Okay. So how do we calculate acceleration in general? What does it mean to have an acceleration? So in the previous class on Tuesday, we looked at a lot of graphs that told us that a lot of graphs that showed us that a car was undergoing some sort of acceleration because the velocity of those graphs were changing, right? We looked at some velocity versus time graphs, the velocities were changing. And if the velocities are changing, that means that the car was undergoing some sort of acceleration. If we want to actually figure out this acceleration, we need to figure out how much was the car's velocity changing every second, which is just another way of saying slope, right? So we want to figure out the rate of change of the velocity, which is essentially the slope. We want to find the slope of a velocity versus time graph. For example, in one of the graphs we did previously, the velocity was, the Model S had a velocity that was changing by 13 meters per second every second, right? So at 0 seconds, it had a 0 velocity. After 1 second, it had a velocity of 13 meters per second. After 2 seconds, it had a velocity of 26 meters per second. So every second, its velocity was increasing by 13 meters per second every second. So what we can say is that we can actually say that the Model S actually had an acceleration of 13 meters per second squared, which means that every second the Model S's velocity would increase by 13 meters per second. So if we want to measure acceleration, if we want to actually say what is this car's acceleration, we're going to use the units meters per second squared, m over s squared. So make sure you write this units down. There should be a box for this. Oh yeah, by the way, there's a graphic organizer that accompanies this lesson. It's the same one that we worked on last time. We are continuing the second half of it. If you don't know what I'm talking about, here is the link to the original one. You probably have a one that you've already started. So, but this is the link to the original one. So make sure you write down the units for acceleration. I would highly recommend you write down how you pronounce it as well, just so you understand what this means in meters per second squared. One thing I do want to point out is that this is meters per second squared, which is different than meters per second. So meters per second is a measurement of our velocity. Meters per second squared is our measurement of acceleration. So that's another thing that I would recommend you make the distinction between. One of these measures are acceleration, one of these measures are velocity. So the key thing I want you to understand here is that when I say I have something has an acceleration of 13 meters per second squared, what it means is that the velocity is increasing by 13 meters per second every second. So after 1 second, it's 13 meters per second. After 2 seconds, it's 26. After 3 seconds, it's 39. So that's what it means to have an acceleration of 13 meters per second squared. So this is a unit we're going to be using a lot. So a lot of the language you're using, a lot of the current language we're using is something like this, where I say, hey, my Model S's velocity was increasing by 13 meters per second every second. Right now, a lot of the language we're using is like this, right? I'm saying my velocity is increasing by 13 meters per second every second. Eventually, though, we're going to change the language so that it says the car just has an acceleration of 13 meters per second squared. And then it's going to be important to be able to realize that what does this mean? What does it mean to have an acceleration of 13 meters per second squared? And you're going to want to make this connection that this really just means that my velocity is increasing by 13 meters per second every second. So this is going to be a little bit of a language thing where we're going to have to understand what this terminology means, that we're having an acceleration of 13 meters per second squared. Okay. So the best way to, I think, practice our use of this sort of language, this sort of physicsy language, is let's do another sort of a problem. Not so much a problem, but as more of a fill in the table. So what I have here is we have a table. It's also on your graphic organizers that for this particular problem. And this particular problem here, we have an object that starts with a velocity of 20 meters per second. And it is decelerating at a rate of -4 meters per second squared. So what I want you to do is I want you to fill in this table with the velocities at these different times. So what is my velocity after 0 seconds? What is my velocity after 1 second? What is my velocity after 2 seconds? Then you're gonna have to make a little bit of a jump here between 4 to 10. And then the last but not least, the most important one, the hardest one, is I want you to write a general formula for velocity for this particular problem. So how might I find a velocity for any arbitrary or any particular time? For example, what if I want to find my velocity if time is equal to 100 or 1,000, right? You may not want to just do it one by one. You might want to write a formula that allows you to find velocities for these particular times. So that's what your goal is here. I want you to be able to write a formula that allows you to find your velocity for this particular problem. A hint I can give you for that is that you're going to notice a trend, right? There's going to be a trend that goes on and on. Yes, are you supposed to see a slide? Yes, you are supposed to see a slide. That is so. Here we go. Okay. Okay, so I guess that nobody saw anything from the last slide. Okay, that's not ideal. I guess let me just go to the last slide real quickly, and I will quickly just go over what I did not show apparently because I don't know what's going on. Okay, okay, so here's what's going on. Okay, so um, okay, that's good. I'm glad you saw my drawing. Okay, so what I wanted to iterate here is that on this previous slide here is that right. If you look at here, this is my acceleration. This is what the acceleration means: 13 meters per second squared. Right, so this is my units for acceleration, and this is what our units for velocity, right? So this is units for velocity. So the first thing we want to do is make the distinction between acceleration units and our velocity units. So one of these is meters per second squared, one of these is meters per second. Additionally, what 13 meters per second squared is that every 1 second, our velocity goes up by positive 13. So after 2 seconds, it should have gone up by positive 26. After 3 seconds, it should have gone up by positive 39, right? And so that's what this means. And so what we want to do is we want to be able to understand this, that this means this, or that this means this. So being able to make that connection is going to be really important, right? Because right now, a lot of the language you're using is something like this, increasing by 13 meters per second every second. We're going to switch from this language into this language, where it says this is just my acceleration, and you're going to have to be able to make the connection that this means this. I think that's about it for this slide. I'm going to go back to the table now. So now this time, I think actually everyone can see what's going on, so it should make sense this time. So first, this table here, what I want you to do is I want you to fill in this table here with the velocities for each one of these times. And then I want you to come up with a general formula for the velocity for this problem for any particular time. Yeah, so I'm gonna put you in your groups now, and then we'll take maybe 5 minutes or so, and let's see if you can fill out this table, and let's see if we can come up with an equation for this particular problem.
Mr. Who, you got to give us a warning.
Yes. So unfortunately, sometimes life is unfair. So
Yeah.
life is too bad. Life is difficult. I would like to give you a warning, but I'm very impatient and I do what I want to do. Maybe one day I'll be more patient when I get older. But for now, you have to deal with very impatient me. Maybe next time. Maybe next time I'll give you a warning. Okay. So let's fill in this table. Let's see if we can fill out this table. So what is our initial velocity, right? This table here is we're trying to figure out what is our initial velocity. So in this problem here, it says our object starts with a velocity of 20 meters per second, which means that initially our velocity is 20. And now that it decelerates at a rate of -4 meters per second squared, it means that every 1 second, our velocity should decrease by 4 meters per second. So after 1 second, our velocity should be 16 meters per second because it goes down by -4. After 2 seconds, it should be 12, so it goes down by -4. After 8 seconds, it should go down again. So it should go down another -4. After 4, and then here it should be 4, goes down by -4. So now we want to figure out what is our velocity when time is equal to 10. So we could keep counting down here, but that is probably not the most efficient way of doing this. I think a more efficient way of doing this is let's see if we can try to be more clever here. So what we know is that every second, our velocity goes down by 4. So that means in 2 seconds, it went down by 8. In 3 seconds, it went down by 12. In 4 seconds, it went down by 16. So that means if we sort of look at this pattern, that means in 4 seconds, right, it should go down by, in 10 seconds, it should go down by -40, right? So it goes down by -4 every second. If we multiply it by the number of seconds, we get that it should go down by a total of -40. So if we started with a velocity of 20 and it goes down by 40, that means our final velocity here should be -20. So that takes a little bit of extrapolation here, but if you were to count this out, right, I'm sure you would get the same answer. Now for the hardest part, how do we figure out a general formula for any time? Well, once again, we're going to look at this pattern here, right? The general pattern is we want to take our starting velocity and we want to combine it with how much our velocity changes, right? We want to take a look how much does what's our starting velocity and how much does our velocity change during that time, and how much our velocity changes is what our acceleration was times how much time was going on. So it decreases by -4 every second, and then we want to multiply this by the number of seconds that has occurred, and this formula right here gives us the amount of velocity we have at any time, and that's equal to 20 minus 4 times t. And as 4 times t tells us how much does our velocity change in t seconds. What is t? T is time. This is a variable for time. So basically t could be 100, t could be 1,000, t could be 10,000, right? It's for any time. So basically what I want to do is I want to be able to plug in a time here to get a velocity, right? We want to write this, it's a variable. I want to be able to plug in a time into this equation in order to get a value for my velocity. Okay, so what we're also going to do here is we're also going to take a look at a graph here. So we sort of looked at acceleration in terms of a little bit numerically, in terms of filling out a table and stuff. I also want to try to look at it, be able to look at a graph here and be able to figure out the acceleration. So in this graph here, what I have is I have on the y-axis, I have the velocity plotted out here, and we have the time here. And so I want you to figure out the acceleration of this graph. So this seems kind of weird, this terminology. What is the acceleration of this graph? You have definitely done this before. The question is, can you connect this terminology to what we've done before, right? So what does this mean to find the acceleration of this graph? So you're gonna have to spend a little bit of time thinking about what this means and then seeing how you can figure it out. But you've 100% done this before in any class, in math class, in this class as well. So I'm gonna put you in your rooms again. This time I'll be nicer and I'll actually give you a warning this time, but not a whole lot of warning, just some warning. So we're gonna get started here. And let's see if we can figure out the acceleration. So, all right, I gave you guys your warning. So,
Thanks.
okay, so let's take a look at our graph here. And let's figure out our acceleration. So, okay, so our acceleration here. So, what does it mean by finding the acceleration of this graph? So, what does acceleration mean? Our acceleration is our change in our velocity, right? It measures a change in velocity. And it's measuring how quickly our velocity changes in time, over time. So what we're really looking for is basically a slope. We're looking for a rate of change of a graph. We're looking for how much does our y change over our x. So in this particular graph, what we find is that every 2 seconds, our velocity changes by 1. So our rise over run is that for every one change in y, it takes 2 seconds. So our rise over run, our slope will just be 1/2. So this tells us that every 1 second, our velocity changes by 0.5, which means that this is just our acceleration. Our acceleration is also just 0.5. So when we want to find the acceleration of a graph, we're really just looking for the slope, because that tells us the rate of change of our velocity over our time. So when you're given a velocity versus time graph, right, to find the acceleration, you just need to find the slope. And vice versa, if you know the slope, right, if you know your acceleration, you know the slope of a graph. So that's pretty much it. So when you are given a velocity versus time graph and you need to find the acceleration, you just need to find the slope of it. So that's just pretty much it for this graph. The next challenge, though, I think, is going to be the fun one. All right, here's the fun part. So usually what happens in a lot of classes is I give you a formula and then you just use it. Right now, what we're going to do is we're actually going to try to come up with the formula ourselves for velocity and acceleration. So don't worry, I'm not going to throw you completely into the fire. I'm going to give you a place to start off with. So we're going to sort of use this graph as a template, as a starting point. So we have a velocity versus time graph. And what we want to do is we want to write an equation that fits this graph, right? So what do I mean by equation that fits this graph? So usually when you graph something, you graph something in the form of y is equal to mx plus b. So a lot of times you might be given this equation, you have to draw a graph from it. Sometimes you're given the graph and you have to find the equation from it. And so the point of this equation is this tells us what my y value is at any given x, right? So the idea is we want to be able to generate an equation for like this for a graph like this, for any graph like this. You can start off with generating a specific equation for this graph, right? But our idea is we want to generate an equation for this graph. Now, writing an equation for this graph in itself is not too complicated. What I want you to do, the challenging part is I want you to start replacing some of these variables, y, m, x, and b, with these variables right here. So there are 4 new variables that we're going to be using. We're going to be using vf, which is our final velocity. We're going to be using vi, our initial velocity. We're going to be using t for time, and a for acceleration. So we have 4 new variables to work with. And what I want you to do is I want you to replace this standard equation for graphs with these 4 variables. So which one of these variables will replace your y? Which one of these variables will replace your x? Which one will replace your b? And I want you to write an equation in this format, but with these 4 variables. So that's what I mean by a general equation that will fit any velocity versus time graph. So basically you are trying to write an equation like y is equal to mx plus b, but using these 4 variables instead. So figure out which one of these variables goes where, and then that will allow you to generate an equation that actually will fit this graph. So I'm going to put you in your groups again, and then I think we'll probably take a little bit more time this time, because I think this is very important and a little bit harder. So we'll maybe take 10 minutes for this. So I'm going to put you in your groups again, and let's see if we can come up with an equation that fits these graphs. Okay, so let's see if we can figure out an equation for these graphs here. So in general, right, our equation format is y is equal to mx plus b. So what do these different things mean? Usually our m is our slope and our b is our y-intercept. So and we want to replace these four variables with these ones. So first off, what is our y? Well, on the y-axis here, we're measuring our velocity. Right, so we know it has to be either vf or vi. So are we trying to figure out what is our y going to be our final velocity, or is it going to be our initial velocity, right? Well, our initial velocity is here, and that always stays the same, whereas our final velocities are changing. So our y is actually measuring our final velocity. We're basically trying to figure out what our final velocity is, right? That's what we're solving for, essentially. So this is going to be our y. What about the rest of these? Well, our x is going to be our independent variable, and the easiest way to figure out what our x is, let's just look at the x-axis. And our x-axis is just time. So that's what our t is going to be. So now we have two stuff left, our slope and our y-intercept. So we've got a 50-50 shot for these, but we don't need to guess. We can get this. So what is our y-intercept? Well, our y-intercept is essentially what is our starting value? What is the velocity we are starting off with? And then another way of saying the velocity we are starting off with is literally saying our initial velocity. So we are starting off with an initial velocity, a vi. Which just leaves us one thing left, which is our slope, and our slope is going to be our acceleration. So why is our slope going to be acceleration? Because our acceleration measures our rate of change in the graph. It measures our rate of change of this graph, and which is another way of saying the slope, right? So if we want to figure out acceleration of a graph, we just need to look at the slope. And so our format for our equation is going to be VF is equal to A times T plus VI. So that is the equation we're going to be working with a lot. One of the main equations we're going to be working with this unit. So here's the equation. Now that it's nicer and pretty. So this is a general equation that relates to velocity to time. Our final velocity here is equal to our initial velocity, or velocity we're starting off with, plus our acceleration times time. Acceleration times time just basically just tells us how much did our velocity change during that time. How much did we accelerate during that time? So this is pretty much just going to be our general equation. Now, another thing what I want you to think about is there are ways that you can rearrange this equation that also makes sense. So this is the slope-intercept form, if you've ever heard that terminology. But I would just call this the let's call this the fine velocity equation with acceleration. Let's call this the fine velocity equation. Now you can also rearrange this, so maybe instead of finding the velocity, we're actually finding the acceleration. So if I actually rearrange this a little bit, what I get is that my acceleration is going to equal my final velocity minus my initial velocity over time. So this is the exact same equation as this. These are the exact same equations. You just have to do a little bit of algebra to rearrange them, but you get this equation as well. So why do we need this equation? Because this equation gives us, I think, a better conceptual idea of what acceleration is. This equation is like, how much did our velocity change? And so what would our final velocity be? This equation here actually gives us a better idea of what the word acceleration means. And in this equation here, what we have is how much we accelerated is how much our velocity changed. So in other words, our final velocity minus my initial velocity, that gives us a change in our velocity divided by our time. So basically, how much did our velocity change divided by time, essentially giving us our rate of change of velocity divided by time. So this is just another way of writing this equation, the same equation here, in a different way that might be a little bit more intuitive for some particular problems. Do you need to know both of these? Technically, no, because as long as you know one, you will know the other. But I think it's just good to sometimes maybe get a more well-rounded approach. So I think this equation here is I think easier to understand in terms of acceleration, right? What does acceleration mean? It just means our change in our velocity divided by our change in time. This equation here is probably more useful not more useful, makes more sense if you're trying to solve for a velocity, for a final velocity. So, but they are the exact same equation. They are the exact same equation. You don't need to memorize the thing twice. So now I have given you a very powerful tool for this unit, is our velocity and acceleration equation. What we are now going to do is we are now going to use this tool to try to solve some problems. So our first problem here, what we have is we have a motorcycle accelerates from 10 meters per second to 50 meters per second in 4 seconds. What is the bike's acceleration, the motorcycle's acceleration? So a motorcycle accelerates from 10 meters per second to 50 meters per second in 4 seconds. What would the bike's acceleration be? So I'm just going to put you into your breakout groups here, and then you'll spend some time figuring this out. If you finish this one early, you can if you finish this problem early, you can start the second practice problem and even exit ticket. But I'm projecting maybe 5 minutes or so for this problem, and then maybe another 5 for the second problem. But if you finish early, you can work on the other 2 problems. So I'm going to put you in your groups now, and then we'll spend some time, maybe 4 or 5 minutes to figure out this problem. So yeah. So we are out of time here, so I'm going to wrap up. So here is the shebang. So we don't have any homework. Once you finish your graphic organizer, hopefully you did, just submit that, and then that should be it. Other than that, I will see you guys on Tuesday.
Thank you.
Bye. Thank you.
Thank
Thank
you.
you.